and welcome to the Blockleaders show with me, Gillian Goff, where today my guest is Ken Anderson, CTO of Tashi Protocol, a position he has held since October 2022. Ken, thank you very much for coming on the show.
Yeah, thanks for having me.
So before we talk about the Tashi Protocol, the Tashi Protocol engine, I'd like to go back a bit to your background. You have a very strong OG background, if you like, in this space. But interesting enough, I was looking through your LinkedIn profile again. You had a military start, and then when you jumped into business, you jumped straight in almost at C-suite. That was pretty amazing that there was no like, I have to learn my ropes something. And also, you did business degrees, but you're an extremely technical man. So tell me, first of all, how did the military experience lend itself to moving into management? As kind of, I guess that answers the question. And where did the techie expertise come from?
Well, yeah, that's a great question, because I think, in the military, I was a non-commissioned officer. So obviously management is part of the role of a non-commissioned officer, responsible for people and just getting stuff done and planning. So there's kind of like a natural fit for a management position. I don't know that really qualifies anybody for a C position. But I was in the military in human intelligence. That was my specialty. So I spent time in intelligence, and when I got out, I kind of like naturally transitioned into sales. And you'll notice that I did sales for a few years. And while I was in sales, I was also playing around with programming. I had done programming as a teenager. When I was in high school, I set up our bulletin board system. If you remember what those are, pre-internet. It was like a local internet between community members and stuff. So I'd set up bulletin board systems when I was in high school, did a lot of just scripting for a lot of internet stuff back then. And so I'd always had a fascination with programming. And when I got into the sales position, I realized that there was a lot that I could improve with programming. In particular, I created something called the risk glossary for insurance. So anytime I would talk to an underwriter about how to position an insurance policy for a client, I'd put all that information into this risk glossary. And then anytime later, anybody else in the company could use the risk glossary to look up like what insurance carrier would support that type of risk. So instead of the underwriters getting calls from 20 people from the same company every day, they got one call a day from somebody who was trying to explore a particular risk category. And then everybody else in the company benefited from it. So really quickly, I was just like, wow, I could use programming to solve a lot of problems. And I was doing insurance sales at the same time I was finishing up my college degree. It was a business degree, but management information systems, which is kind of like a mix between programming, computer science, and business.
Okay.
And the whole purpose of it was like, how do we take information and make sense of it in a way that is meaningful and actionable on the business side? And so I have the university degree for doing exactly what I do professionally, but I also was already kind of programming to solve a lot of the problems in the business case when I was doing sales. And then I was moonlighting, building an online university for Pilates instructors and stuff like that. And so I'd done a couple of these projects, and at one point, this startup that was building a telecom channel sales SaaS platform called me up and said, "Hey, all that stuff that you've been doing, we want to build some of that, specifically the educational stuff, for our channel sales partners. Would you come on as our CTO?" And I was just like, I don't know if I'm qualified to be a CTO. Like, I was kind of already the CEO of my own little private consulting firm, but it's not really, it was just me doing stuff in college, right? It's not like executive experience per se. And he basically said, I tell you what, I'll invest in you for a year to learn this industry and to learn how to become a CTO. So I spent the next year like really digging into the telecom space, understanding the entire business support systems layer of telco. We started to build a team. I got a lot of on-the-job training and some formal training in the executive side of things. So I was CTO and the president of the company at some point. And so I got a lot of training. We spent 3 or 4 years building that company. And then at some point, I decided to leave and start Launchbadge. And Launchbadge was my custom software engineering company that we started in Sacramento. And so I kind of went from CTO to CEO, solving those types of things. So that was kind of like the transition from like, I was in military, had some management skills, went to university, got some more of the technical skills and understanding the spaces, and then kind of just I would say it's almost luck. It was like providence that I was able to move into a CXO position because a startup needed somebody with my skill set. And I think that particular engagement was the one that kind of put me into a comfortable position as a CXO. And then I continued on as a CEO and then CEO of different companies and
Mhm.
stuff like that. And I at time I played a role as interim CTO of various companies.
Yeah,
So I've
no,
got
see,
20 years of that now.
yeah. I was going through all the different companies, but that progression was interesting. Question for
Yeah.
you. You have got quite a lot of experience, different companies. Are there would you pick out any experiences with any companies that have uniquely qualified you for your current role as CTO at Tashi?
Yeah. Well, I mean, there's a combination of like Launchbadge is what, 9 years old now. It's a software engineering company, and I've been the CEO of Launchbadge. And Launchbadge for the last, I'd say 7 of those 9 years has been very deeply involved in very deep tech of the blockchain space.
Mm,
So a lot. So basically, I would say like 2015, 2016, we started getting involved kind of loosely in blockchain. In 2017, we got very, very active, meaning that we were writing smart contracts, which is more the high level stuff of blockchain. But then we started writing our own, consensus algorithms and writing low level tooling and stuff like that for the blockchain space. And so that was really where my team shined. So I had partnered up with a guy, Ryan Leckie, who's my CTO now at Launchbadge. And to be clear, Launchbadge is kind of on autopilot right now. It's got a few projects that it's maintaining, but Ryan's off working on another project and I'm working on Tashi. But the two of us, when we built Launchbadge, he was kind of like the technical genius, and my job was like the architecture side. So
okay.
when people came and said, how do we solve this real life use case using blockchain? I would go in, help them find the fit, architect out the solution, and take it back to Ryan, and then Ryan would build it. And so that was kind of our relationship. And
No,
we had a ton of projects. And again, our focus was always, let's find the real world use cases. Like, let's
mm,
not do this because of hype.
yeah.
If it doesn't fit, it doesn't fit. And quite frankly, that's what led me to Hedera Hashgraph in the first place. Was we were trying to build a project. You're very familiar with it, with Mingo, and we were
Yeah.
going to do on-chain messaging, and realized that there really wasn't a protocol that was going to satisfy the performance requirements of like a real-time messaging app on blockchain. And so we ended up discovering Hashgraph before there was even a Hedera. I got involved with that, and then I ended up becoming the chief developer advocate of Hedera. Um, Kind of, again, Launchbadge was kind of on autopilot. But the cool thing was Launchbadge picked up a lot of work on Hedera. So
Mm,
between me working for Hedera and Launchbadge, and I had to be really careful about those roles. I wasn't allowed to refer any work to Launchbadge and my role in Hedera. So it always had to be like a more organic fit for
mm,
Launchbadge to get involved. But Ryan had built an entire team that had that really deep experience in blockchain and specifically in Hedera and consensus algorithms. And what had happened was after a few years, I had left Hedera. As soon as I left Hedera, Bobby and I had started talking again. So Bobby is my co-founder in Tashi. And he and I had been talking for years in the context of Hedera. And when I left, and specifically the year after I left Hedera, he had called me and he said, "Hey, I want to do this Tashi thing." And I said, "Well, tell me about it." And he said, "Well, why don't you fly out to Singapore and we'll chat about it?" And I was like, flying from the US to Singapore is like, that's not a decision you make lightly. But I think he was doing it to kind of test my resolve and see if I was really serious about potentially engaging on a really cool project.
yeah.
And so I flew out, met with Bobby, met with his partner Jay, and the three of us ended up after that visit forming Tashi. And that was kind of the start. That was the journey from military all the way up through to Tashi.
Yeah.
And if we think about like what Tashi is, Tashi went ahead and acqui-hired a good chunk of the Launchbadge team. So a lot of that expertise from Launchbadge came over with me into
Well, that's
Tashi.
cool. Yeah. Okay. Because my next question after that question I was say, how did you and the founders meet? So you've been chatting for a while beforehand, and then you came together at that meeting in Singapore. Was that the first time? Was that the first time you
Right.
met in person, or had you
Yes.
met? Okay.
Yeah, so Bobby and I had been talking for a number of years. He was one of the first ambassadors in the ambassador program we developed for Hedera.
Hmm.
And he was very much involved in the initial fundraising in Asia for Hedera.
Yeah.
And so he and I had talked for years. And there are even times when he would call me up and we'd just sit on the phone for 3 hours and talk. Right. So we had a regular conversation going for near 6 years.
Hmm.
Um, and that right there was the first time that I actually saw him face to face, was him going, "Hey, I want to do something. I think it's worth your time. Come fly out and let's talk about it." And I think it was a 13 or 14-hour flight later. I'm in Singapore, and we're talking about this project. I spent a couple days with him and Jay and a few other people that are involved in Tashi. But yeah, that was the first time that we'd ever even seen each other face to face, was on that flight.
That's amazing. Well, I think it's important that you say you had such a strong commitment and friendship and relationship prior to it. Otherwise, you wouldn't have jumped on a plane. So tell me, with Tashi, you're anticipating my questions each time. So you mentioned earlier that you were very big on solving real world problems with blockchain.
Right.
So what problem is Tashi solving?
Yeah, that's an amazing question. Now, the answer is much bigger than what we are doing, what we're focusing on.
Hmm.
But fundamentally, what we've done is kind of learning from the various voting algorithms out there. I mean, we've looked at Hashgraph, we looked at Aleph, BFT. We've even gone back and looked at like Lamport timestamps. There's lots of BFT algorithms out there, and we've looked at them and kind of put together our own consensus algorithm in Tashi. There are a lot of similarities with some of those other protocols. In particular, like if you look at Hashgraph, we've got the two-phase consensus protocol where we've got a gossip and a virtual voting, but our virtual voting algorithm is very different than what Hedera does for their virtual voting, or Hashgraph does. And so, but we built this because we saw the potential of this type of BFT algorithm, this type of asynchronous BFT algorithm. The idea that you don't need to count votes, you don't need to broadcast proposals. There's not multiple rounds to voting. You just gossip as fast as you can, and then each node independently calculates the consensus or the answer. And the magic of the algorithm is that everybody ends up calculating the same thing. There's a mathematical guarantee that that happens. And so we were looking at that going, this fundamentally allows multiple parties to interact with each other without having to trust each other or
Hmm.
trust a middleman,
Yeah.
and guarantee that the logic will be encapsulated in whatever application they're all running, and that will stay in sync. So there's kind of like this deterministic guarantee that all of their application states will stay in sync. And we said, well, what could we do with that?
Mm.
And there are a lot of things. We've already kind of done a few proofs of concept. We wrote an SDK for the Unity gaming engine, which allows you to have multiplayer games without servers and without hosts. So you can imagine, if you wanted to play Minecraft with a few of your friends, you just start Minecraft and start playing with each other. The world is synchronized between you. The seed to the world is synchronized between each other. So you end up having this multiplayer game without having to have somebody have additional power or authority as the host, if you will.
Mm.
And if anybody tries to mutate their state, meaning they go into what's called OP mode, or the host mode, and they try to mutate their local state, it'll get rejected by everybody else in that game. So there's kind of a fairness and kind of an anti-cheat mechanism to it,
Yeah.
which works great for gaming. And so we built that SDK, we demonstrated it. We've been working with Unity on how to work it into their stack more organically. We're going to be releasing the SDK into the Unity marketplace soon. I've spoken at a few of their conferences. So already we've established some pretty good relationships in the gaming space from that. But we've also built a message queue,
Hmm.
which is used in almost all software stacks, all major scalable software stacks. Everybody's got a message queue, and it's often a barrier when you're dealing with multiple parties. If you're one company owning your entire stack, it's probably not a big deal.
Hmm.
But if you wanted to have a shared message queue with another company or another application, then the question is, who owns the keys to that message queue? How do we guarantee fairness? How do we guarantee synchronized message queue states? And those are things that we've been able to demonstrate. And in particular for IoT, that's really useful because IoT lives on message queues. So So we've built a few of these use cases. We call them mesh apps. And the way we think about it is we've got our consensus layer that we've built. And then on top of that, we've got a mesh network, which you establish between peers that
Mm-hmm.
uses our consensus algorithm to keep everybody in sync. And then on top of that, you've got a mesh app that is the application state or the application layer of that mesh net. And so we've built this stack and
Mm-hmm.
we're looking at it and we're going, okay, we've solved some gaming problems. We've solved some message queue problems. And we're looking at this going like, we can do decentralized databases. We can do decentralized and shared sequencers. Like there's all these things we can do with technologically superior algorithms to ensure that the consensus is consistent and fair. And so really cool things we could do. Now, what we're focusing on is we're focusing on the fully on-chain gaming space because that's where our roots come from, right? That's where all of our
Yeah.
relationships and connections are. And it's a hot topic and it's something that's important to the Web3 space. So our focus right now, probably for the next few years, is going to be on that fully on-chain gaming space. And there's an additional component to that. If you're familiar with like the DPIN stuff, the decentralized physical infrastructure networks, the idea is that you can provision resources from third parties using the DPIN network. So you can think of us kind of as like the DPIN for fully on-chain gaming. So it's kind of taking two major use cases in the Web3 space and applying it in a real world scenario that Web2 game developers get benefit out of it.
Okay, that's just the real world application. That's the long circle round. So
Yeah.
that means that means then what you're talking about is that gaming, because there's been so much hype between Web 2 and Web, talking about the gaming here now, so it's the other two, so much hype, but it hasn't been realized because there's too much delays, grinding, all this type of stuff. So this gets around this problem with gaming. And some of the features I know I've read, it's high performance, low latency, cost
Yeah.
efficiency. These are all things that are very important to people who want to game for fun and not game because there's no welfare state in the Philippines when there's a COVID crisis happening. We're all very worthy,
Right.
but it's not what gamers are going to do. They're not going to do that. So you're solving that problem.
Yeah. Well, and I'm glad you brought that up because, you know, up until now, the Web3 gaming space has been really focused on GameFi and play to earn and collectibles, which are all, you know, noble use cases, but
Yeah.
they really don't touch the heart of gaming, which is like, how do I ensure that I have a fair gaming experience? How do I ensure performance? You know, there was something called Block Wars way early in the days that was built on Ethereum, right? I think it was in 2017. Block Wars launched on Ethereum, or maybe it was early 2018. That's probably 2017. But the cool thing was that it was kind of like you would go around and look at a real world map, and then you would like buy land on a real map with Ether. And then you would surround other people's land with your Ether, and then you could attack their land for Ether. And the more land you had surrounding it, the higher chance of success you had. And it was all smart contract based. And it was a fun game, but it was one of those games of like, you made your move and then you waited 6 minutes to see if your move worked. Right. So it was like a really slow game. And I thought it was like the perfect use case to demonstrate like how you could use blockchain for gaming, but it was a 6 minute wait time to figure out if you were successful or not. And so I thought it was incredibly fun, a great proof of concept, but we're still kind of stuck in that. Like that when we say fully on-chain gaming, we're saying that like, no, the game itself is leveraging a blockchain or distributed ledger tech to support the game playing experience itself. How do we ensure a fair state or a consistent state between the game players? And so that's been the challenge is, you know, even up until now, it's everybody's still focused on GameFi collectibles and play to earn. Again, noble causes, and I think that there's a place for all of them, and I think they're very useful, but we still haven't touched the internals of the game. Well, what we did with the Unity SDK is we proved that you could actually have a consensus engine running behind the game. And what I mean by that is every time I press a button on my keyboard or my mouse to change some state of the game, it first goes through and gets consensus with every player in the game. Well, 2/3 or more players in the game. And then it commits that move to everybody's computer. And that sounds like that would be a really slow experience, except for we've got the consensus finality down to approximately 30 milliseconds. And if you think of gaming, most gaming is okay with that extra 30 milliseconds. Some gaming is not. I will say straight out, like very twitchy games, first person shooter games, without some serious work on the net code, it's probably not a brute force fit. I'm sure there's some magic you can do with netcode to make that work. But even that latency, we're improving. Like there are things we can do with the GPU to improve that speed and make that latency lower. But as of right now, even with the state that we're in right now, we're getting 30 milliseconds of latency and thousands of transactions a second, where most games only need a few hundred a few hundred transactions a second, maybe a couple thousand transactions a second. So we more than support the gaming use case for the vast majority of games out there, meaning that we're actually taking Web3 tech and we're making Web2 gaming benefit from Web3 tech. It's not like in Web2, if you talk to any Web2 game developer, they kind of look at blockchain with kind of a sneer, because they're just like, oh, you guys are it's just Ponzi schemes, people are trying to sell digital stuff. And it's like, it doesn't benefit my game experience or my development experience as a Web2 game developer. But I mean, we've been talking to the biggest game development companies and publishers in the world, and all of them are excited about the idea that we could have this. Now, Web2 gaming takes a long time to adopt because they've got long development cycles. So we're continuing with that effort. But that being said, the Web3 folks can get ahead of the game. They get to use this technology early because Web3 folks are willing to take that early adoption risk. And there's lots of new stuff getting developed now, even in the indie space or in the Web3 space. And a lot of those people get to take advantage of what Tashi's offering. So if you think about that, okay, so we've got a game state where the game session itself is kind of a private network blockchain, and there's stuff happening in that. So you can imagine going to your favorite public network or something like Immutable X and grabbing your assets and loading it into the game as an inventory, playing the game, and knowing the game itself, every peer is checking and validating each other in the game. And so as you're playing the game, if tokens get transferred in game, they can happen at that incredibly fast speed on a private network with a consensus algorithm. And then at the end of the game session, that state or state proof gets sent back to the public network and settles there. So we're looking at a lot of roll-up technology. We're looking at Arbitrum Orbit. We're looking about how do we integrate with different networks to support the loading of assets into a game and the settlement of assets at the end of a game session. But the game session itself is actually running on Tashi, and that's the incredible part, right? Yeah. And so this is kind of the first time that we see Web3 fundamentally adding value to the game space.
So this is the first, isn't it? No one else is doing this.
Yeah, well, there are a lot of people who are trying to do this. Like there are a number of people who have built game engines that leverage blockchain tech.
Yeah.
I think the challenge is that, if you take a proof of work or a proof of stake or any type of proof of algorithm, or even some of the quote unquote BFT algorithms, you take Raft or Paxos or something like that, they're too chatty to get that kind of latency. Like it just takes too long. There are projects out there that say, oh, we can get less than a second of latency. And there are some that even say we can get less than 500 milliseconds of latency. It's like, well, in the gaming space, you got to be less than 100 milliseconds of latency.
Yeah.
You have to, or else you press your click, your mouse button, and it feels like it takes way too long to register on the screen.
Yeah. Yeah.
So just technically speaking, if you want to retain the security level that Web3 promises and the performance that gaming requires, there's nobody else that does it at the same scale that we do it. Some people will sacrifice security for speed, and some people will sacrifice speed for security.
Yeah. And you're saying why? I think what you're identifying is, say, Web2 gamers do not care about owning stuff. They really don't, because they're really paying for stuff. But it's a nice byproduct if it can happen within the parameters of what they expect. So are you a gamer, by the way?
Oh yeah. Yeah, I'm a hardcore gamer.
Yeah,
this is why Tashi was so exciting to me, because when Bobby and I were talking, it was like, what can we do? And I remember initially we were like, well, let's not get into DeFi or fintech. Like there's a lot of regulatory risk. There's a lot of stuff we have to do to kind of prepare ourselves. There's going to be a lot of legal prep that we have to do. What can we get into where there's low regulatory risk and a lot of activity and attention? And that was gaming. And which for me was perfect because I'm a gamer. So when Bobby said, yeah, let's focus on gaming, I was like, all right, now we're talking my language, right? So,
Yeah.
and all of our developers are gamers. So, and some of our developers are even like indie game developers, and we even have
Oh,
some people who
wow.
are emulation developers. So emu dev. So we've got a deep bench of gamers, and we can very quickly spot when something doesn't appeal to us.
Mm.
And we tend to come to a consensus about like, oh yeah, that's valuable or that's not. And yeah, but to your
Yeah.
point, you're absolutely right. Most gamers don't care about ownership. If you look
Mm.
at your World of Warcrafts, if you look at any of your games, your Fortnites, it's like people are spending real money to buy skins and to buy points and buy stuff, and then it's locked into that game ecosystem owned by the publisher,
Yeah.
and nobody cares. Like
No.
nobody's screaming to own those things. You know, if you lose it in game, they'll make a complaint, and you know the company will restore it to you. But that usually means there's a glitch or somebody hacked your account or something like that. But like the company can restore that. So there's not a huge demand for ownership.
Mm.
Even the pay to play, or the sorry, not the pay to play, all of them are pay to play now, but but even the play to earn model, you know, most people don't really care about it. They're actually okay spending money for their entertainment. That's why we
Yeah.
pay money to go to movies. That's why casinos exist. That's why all of these things exist, because people are okay spending money for entertainment. So while those are values that I
Mm.
I look at and go like those are good values, and I could see that being useful in the future. Right now, that's not what people care about. That's not the driving
No.
reason for engagement. What people want is they want to get rid of cheating.
Yeah.
That's what people
Yeah.
really want to do. Is there's nothing more frustrating as a gamer, especially a multiplayer gamer, to have somebody else cheat and it ruins your game experience. And so I think that's really where our ability to fit in works really well. But that being said, we're not just limiting ourselves to the game session. What we're saying is the game session is the driving function,
Mm.
it's the forcing function for our entire stack. But we want to be able to support all kinds of things in game, microtransactions, game persistence between game sessions, identity, all these things that you have in the Web 2 gaming space. You can
Mm.
go to an Excel Byte or a Beamable or a Loot Locker or a PlayFab. Like these are platforms where, as a Web 2 developer, I pay the company and I get all of these features that I can incorporate into my game. And what we're saying is we can do the same thing, but we leverage our community as a resource pool and compensate them for the leasing of their resources to satisfy those requirements. So what we're saying is like, if you're a Beamable or a PlayFab or an Excel Byte, they're managing all of that infrastructure. They're taking all the risk to host that infrastructure in their data centers or to rent that infrastructure from AWS or Google. And then they're reselling it to the game developers. What we're saying is, what about all of our gamers and all of our community who have unused resources sitting on their desks all day for 80%, 90%, 95% of the day? Why don't we just repurpose that and utilize that to support the exact same use cases that the Excel Bytes of the world are providing? So it's like and because we have the compensation model built into it, which we're going through all the details of like how the incentive program works in Tashi. But if the compensation model is built correctly, then consumers are getting compensated for a machine that they're not using. And the Web 2 developers are getting the same experience they're getting right now in the Web 2 space, potentially at a savings. We'll see how that works out with the math. But either way, we're optimizing the resources that exist in the world without having a whole bunch of additional underutilized resources. Because what happens when Excel Byte leases a bunch of equipment, and you know everything in gaming is in cycles too, what happens during their down cycle? Well, they got all these big machines that are sitting there doing nothing. Well, wouldn't it be nice if Excel Byte could take that underutilized resource that they have sitting there and inject it into the Tashi ecosystem? And now we have the exact same resources that are supporting the current Web 2 developers, now supporting the Tashi developers, Web 2 or Web 3. So we're really trying to optimize for resources. Like
Yeah.
the real limiter coming up quickly, and I think everybody sees the writing on the wall, is that we're going to come into a huge demand for chips, specifically GPUs, but also for CPUs as we're moving into this very heavy AI machine learning space. And there's going to be a massive premium on that. So
Yeah.
we need to optimize what we have now as soon as possible so that we don't run out of those resources when that time comes, that those demands go up massively, and now the cost goes up because those demands go
Yeah.
up. So it's like, well, let's optimize the underutilized stuff now before that time comes.
That's interesting. I haven't heard. You've said
Sorry,
a few
that's a
things,
that's a big vision. Sorry.
isn't it? Well, you said a few things. I'm going, oh, I haven't considered that. I haven't considered that. Or maybe I had thought about it. You're putting it all together. Tell me, as part of this journey that you're on, who are you partnering with people? What
Yeah.
other experts are you bringing in? And why?
Yeah. So, a lot of our partners are in the Web2 gaming space. So, I could say that, like, like Beamable, we have an agreement with where they're actually going to be using our SDK as part of their multiplayer offering.
Mhm.
We're in discussions with a couple other Web2 companies that are doing similar things. We're part of the NVIDIA, their, what they call it, their incubator program, accelerator program. So we're coordinating with NVIDIA and how we offload a lot of our cryptographic functions to GPUs.
Mhm.
If we look at the Web3 space, we're working with Aether, who just had a very successful start to their fundraise. They're doing a really cool model of node sales,
Yeah.
which I think they've raised a little over 30 million. It was something like 20 million in like 2 days or something like, or 24 hours or 48
Mm.
hours or something like that.
Impressive.
And I think right now they're just over 30 million that they've raised through their initial node offering. And great team, by the way. I love their tech, what they've done, and we're looking at potentially partnering with them for the GPU stuff. And there's another use case in the gaming space that fits really nicely into the Tashi platform. I won't talk about yet. I think once we get the messaging sorted on that, we'll announce that. But with Aether, there's at least two really cool use cases that we're looking at with Aether. And then again, in the Web3 space, we're looking at, we're chatting with the folks at Anchor and looking at Arbitrum and Arbitrum Orbit, looking at all the L1s as well.
Mhm.
Lots of discussions going on there about how we do the on and off ramping of assets into a Tashi game session. So we have lots of exciting discussions going on, a handful of like really concrete partnerships that we're moving forward on. One in particular that's really exciting. I guess everybody who's listens to this is going to kind of get an exclusive, but one in particular is this project in Indonesia. Um, it's basically a Twitch replacement because in Indonesia, Twitch is banned because of modesty reasons.
Oh,
And so this company has basically come out and in a very short time, like in less than a year, they have over 5 million users, a million daily active users, and 200 streamers, sorry, on their
mhm.
platform. And the model is incredible. The idea is that they get advertising revenue coming in, and then they split that advertising revenue between the streamers and the viewers. So the
Okay.
viewers earn for engaging with the streamers. And then when they earn in their platform token, and they
Mhm.
can swap that token for a streamer's token. So each streamer has their own token too. And then you can cash out the platform token at any time for real money. And the idea there is that, the most popular streamers are going to get direct ad revenue, but they're also going to get fan revenue. And if you're a fan, if you're a viewer and you're just like, I'm just going to pocket this, it's like, okay,
Okay.
that's fine too. Totally acceptable. So it's a really cool platform that has all of the spirit of Web3, but really hasn't integrated any Web3 tech. Everything's been built kind of as a proof of concept in-house, super robust. It's incredible what they've done, but we're going to help them make that migration to Web3. A
Wow.
lot of the internals of that technology are going to be running on Tashi. Even the message queue that we built is going to be there to support a lot of their real-time chatting functionality. So we're going to be using that partner as kind of more of a design partner, if you will,
Yeah.
to validate a lot of our assumptions and to really refine a lot of our interfaces. So yeah, really
Well,
exciting
that's
partners we
exciting
got lined
because
up.
I would have heard about projects similar to that back in 2017, but I have no idea where they went to. They didn't maybe they had more ideas than practicality. So
Yeah.
tell me two last questions then. Are you going to be, where can people come and find you? Are you doing road trips? Are you doing conferences?
Yeah, that's
Where are you
great. Well,
hanging out?
I would say the first place would be to go to tashi.gg.
Mm,
So tashi.gg.
yeah.
Um, so that'd be the first place to go. Check out our docs. Our docs are growing, but I think the cool thing about it is we've really captured the fundamentals of why Tashi
Hmm.
in the first few pages there. Also join our Discord, which from our website, you can get to our Discord channel, get in there, ask all the questions. We're going to be really I'm not going to say much else, but I think the entire Web3 community is going to be very excited about the announcements coming pretty soon with Tashi. And then obviously we've got token 2049. I would say if somebody's going to be at token 2049, coordinate with us through Discord, but we're going to have a handful of our exec team there. They'll probably be in meetings all day, but there's going to be some time for them to walk around and meet people and stuff. So absolutely coordinate on Discord if you want to meet with any of the core team there at token 2049 in Dubai. And then we've got a bunch of events throughout the year that we're going to be looking at. I'm probably going to be at Consensus in the end of May, beginning of June, I think, end of May, the last few days, right? So I'll probably be there because if I remember correctly, that's in Texas. So I don't know where everything is, but I just know that we have things on the docket for everybody to start attending. So we've got a lot of, we're going to be out and about. Let's just say that we're going to be available. We'll probably be hosting some dinners and stuff at some of these events for some of the people in our ecosystem.
Brilliant. Final question.
Sure.
Where did the name come from?
Oh, that's a Bobby question.
Ask Bobby. That's fair enough.
Ask Bobby. I'm not going to pretend that I remember exactly what it means, but it has a very positive meaning, and I think it comes from some like ancient Indian word. I don't know if it's a Sanskrit word or something like that, but Bobby, it's a
Tashi.
Deep meaning to Bobby.
Well,
but
it's very handy.
Yeah,
it's
exactly.
very accessible. It's new.
It's easy to say. It's not a common word, and it's 2 syllables.
Tashi.
And easy syllables to say. Yeah.
And it fits on a hat.
And it fits on a hat. It looks beautiful on a hat. So
brilliant. Well, thank you very much for your time today. It's been very interesting.
Sure
Lots of things came up there that I wasn't expecting. And one of them, no one has said to me before, which is interesting. It's a fairly basic one, that Web2 gamers want performance, obviously, but they want to make sure that people aren't cheating in those multiplayer games. That's an obvious one, isn't it? It's just that Web3 have not thought about. It's like, oh, own your NFTs. No. So in a very
well, there's some good projects out there, like there's a project Mud, there's a project Dojo, and a lot of these are kind of working smart contract logic into games. I think they got half the problem solved. But there's still the fundamental, like in game, how do we ensure that everybody has the same state? And the answer to that could be, well, let's reach out to a roll up, an L2 or an L3 and anchor our trust in one of those networks. And that could be an answer, but I don't think that scales and that's not performant. So having the actual consensus live in the game so that every game client is part of the consensus is a massive change in the model of trust. And where games are too small, we can always augment that with third-party consensus nodes. Totally fine. That's all part of our DPEN platform. Where people are concerned about collusion in games, it's like, okay, well, that's why we have decentralized matchmaking, so that you kind of get like a more random matchmaking that helps kind of mitigate some of that risk. So there are questions about, security and stuff like that, but I think fundamentally, if you have the right building blocks at the core of the game itself, all of those other problems get much easier to solve. And I have to commend those other projects that are trying to do that, kind of like in-game anti-cheat, shared state, provable state is what a lot of them call it, or authenticated worlds and stuff like that. But it's like the vision's right. The technology is about halfway there. And here we're coming in and saying, well, we've got a fundamental core piece of that's going to make it actually viable in the final state. So anyway, there are some people who've talked about it, but to your point, we don't hear a lot about it unless you're specifically focused on it. And even then, it has to happen at scale where Web2 developers are willing to take a look at it. And I think that's the major differentiators. We started with Web2 and used that as our requirements for developing it. And we went all the way down to the consensus algorithm to solve that problem. Because if you're not starting at the core consensus, you're trying to take something that doesn't fit and shove it into a set of requirements that the Web2 guys need. And we're just saying, if we can't solve this fundamental piece, then the rest of it's not worth chasing. Yeah.
No, very interesting. I'm looking forward to reading through my notes after this call. Thank you very much indeed, Ken. You make it sound very, very easy. Is that what? You make it sound very, very understandable. Thank you very much.
Absolutely. Thank you.